Hello students. So we can explain the length contraction. We can derive the length contraction formula easily with the simple concept of Coulomb force and the magnetic force acting between two point charges. Coulomb force acting between two point charges at rest, while two point charges are in motion. There is a relative motion between the observer and the point charges. There is two type of force: electrostatic force and Coulomb electrostatic force and magnetic force. So with respect to this observer, electrostatic force, electric force as well as magnetic force acting between them. Therefore, total force acting between these two charges is equal to electric force plus magnetic force. Whose direction is opposite direction. That's why you subtract this equation. So this is the formula from this concept equating these two forces, because we know that with respect to an inertial frame of reference, force acting between any two observed objects with respect to any observer is equal to the force acting between these two observers observed by another observer from another inertial frame of reference. So two forces must be equal in magnitude. So this is the formula, and we got the result. L is equal to L naught root over 1 minus v square by c square. But here look at the picture. Here distance between two point charges with respect to the rest observer is L naught. But this charge, the distance between these 2 point charges with respect to another observer who is in motion is L. Written here L. So L and L naught are not same. These 2 point charges, when 2 point charges are at rest, the force acting between these 2 point charges is equal to only electrostatic force. The gravitational force is negligible. But when these 2 point charges are in motion with respect to another observer, let 2 point charges are here and I am moving out from this. So with respect to me, these 2 point charges is observed by me, which are at a distance L naught. But with respect to me, this length it changes to another length. This change may contracted, because when this length is contracted, this length become reduced, this length changed, then Coulomb force increases. And when Coulomb force increases, then there is another electromagnetic force to adjust the total force, which has to be acts opposite to the direction of the electrostatic force. These two forces adjust the resultant force. So with respect to an observer and which is motion, with respect to this observer, this force is equal to the same force with respect to another observer. So when we observe the length between, this is the another figure also. This is the expression I have done. When I do this expression, I first reduce this total expression here, and after that I go to this here. That's why I show repeatedly. This is the expression. I am Soubhagya Basuli, physics teacher, MSc in physics, silver medalist, first class second, B.Ed first class. I am the teacher of Kanchanpur High School, Bankura district, block 2, West Bengal. If any discussion, any query regarding these classes, you can call me within 12 o'clock. Okay. Now I am telling you another point, that when one body is at rest, the length of the body is called L naught. But when this body is in motion, or when this body away from me or coming towards me, whenever there is a relative velocity between the object and the observer, the length of the body may change. Length of the body contracted. So in the first class we saw that when this is the length of the rod with respect to an observer, but when this is in motion, you look at this, look like this. When you observe from raised frame, the length of the rod is just like this. But when you observe from a moving frame, you observe that the length is contracted like this. This is not actual fact. There is function. There is a sliding function. But actually, when rigid rod or fixed length moving, this phenomena is observed. So this is the phenomenon of length contraction. So length contraction phenomenon can easily be explained with the concept of electrostatic force and magnetic force. Here we discuss these events of length contraction with the help of electrostatic force, Coulomb force, and magnetic force here. So this formula can be derived with a simple eye, and this formula can be understood by the below HS level student, 10th class student who have simple idea about Coulomb force and magnetic force. They can understand this formula, this derivation. In the next class, I will discuss about another derivation according to me, a new concept of physics. I am trying to discuss the physics according to another method, another concept of view. I cannot change the law of physics, but I can explain the physics with the new concept of physics. My point of observation, according to my point of observation, when I observe any problem, any situation, I explain this in different ways, in different approaches, and which approach is very easy to our students. I give them the same various technique, various approach, which is familiar to them, which is easy to them. I explain different approach. I don't know which approach is comfortable to them. That's why I discuss the same problem in different approach. In the next class, I will discuss about the length contraction here, time dilation, mass variation, E equal to mc squared. There are so many formulas regarding Einstein's special theory of relativity. I write here this formula. I try to discuss this formula. I try to explain the formula. I try to derive this formula in different approach. The main formula is famous equation is E equal to mc squared, and mass variation m equal to m naught divided by root over 1 minus v square by c squared, and another equation is length contraction, which is derived here, which have been derived here. N is equal to n naught root over 1 minus v square by c square, and there is another formula of time dilation. T is equal to T naught divided by under root of 1 minus v square by c square. These are the famous formula regarding Albert Einstein special theory of relativity. These are the formulas special theory of relativity. This formula was given by Albert Einstein. This formula was given by Albert Einstein. I respect this scientist because who gives this idea. From this equation we can obtain energy. Is the energy crisis in our daily life. Mass can be converted into energy. Energy also converted into mass. This is the mass energy formula. This is the mass variation formula. This is the rest mass. This is the moving mass. When the charge particle in the body is in motion, then its mass may change. But charge particle, nature of charge is invariant. Mass may vary. This is the length contraction formula. Length of the body changes with respect to velocity. As v increases, length of the body decreases. When v becomes c, then length of the body tends to 0. This is the another process. So velocity of body can never be equal to velocity of light or greater than equal to velocity of light. This is the basic theme of the special theory of relativity. If we put this v equal to c or greater than this imaginary or 0, which is quite impossible, m equal to infinity and v equal to c. This is impossible. Mass body any matter may not have infinite mass when v equal to c and v equal to c. But when v equal to 0, then mass of the body is equal to m naught. Here when v equal to 0, the length is the original length. With respect to rest frame, the mass is equal to L0. And this is the time dilation. With the time with respect to a rest frame is equal to T0, and with respect to another frame, moving frame, T is equal to T0 divided by 1 minus square. When the observer is in rest frame, when the observer is in rest frame, that is B equal to 0, then T equal to T0, M equal to N0, L equal to N0. There is no change at all. But when V not equal to 0, then L not equal to N0, M not equal to L not equal to M naught, L not equal to M naught, and T not equal to T naught. So length, mass, and time are different with respect to different observer. This is the concept of special theory of relativity. So I will finish and discuss the next topic in the another classes. Congratulations to all of my students, all of my respected teachers, and my colleagues who give me such type of opportunity. Now I finish the class. I will meet you in the next class. Thank you. Goodbye, Mr. Black.